Hello, this is Professor Clark. In this Chemistry Success Center tutorial, we're going to focus on using molarity as a conversion factor. So when we talk about molarity, what we're describing is how many moles of solute are present in every 1 liter of a solution. You'll often see molarity abbreviated with a capital M. Sometimes that M is italicized or perhaps underlined. When you're seeing that capital M, it's telling you we're talking about a concentration that relates the amount of solute, the substance dissolved in the solution. So if we're talking about sugar dissolved in water, the solute would be sugar, for every liter of the solution. And so in that sugar water example, our solution would be the sugar and the water mixed together, the total volume of that solution. Now, you can solve molarity problems by treating this as an equation where you have 3 variables, molarity, moles of solute, and liters of solution, and you plug in any 2 and solve for the third. But what we're going to look at in this tutorial is how do we use molarity values as conversion factors. So let's say that we're told that a solution has a molarity of 0.760 molar. What that is telling us is that in every 1 liter of that solution, there are 0.760 moles of our solute, whatever that solute is. So looking at a concrete example here, if this was a 1,000 milliliter, which is equivalent to 1 liter flask, and it was filled to the line with solution, in that 1 liter of solution, there would be 0.760 moles of whatever the solute is. And the reason that I'm highlighting this is because this is the key idea in using molarity as a conversion factor. Whether we talk about having 1 liter of the solution or having 0.760 moles of the solute, those are describing equivalent physical quantities. Because if I have 1 liter, in that 1 liter, there's 0.760 moles of the solute. If I have enough solution to have 0.760 moles of the solute, I must have 1 liter of the solution. So when you see a molarity, you can think of the number that you're given, the 0.760 in this case, as telling you how many moles of solute are there for every 1 liter of the solution. So let's take a look at how this works in problem solving. In this problem, we want to figure out what is the volume in milliliters of a 0.760 molar solution of sucrose that contains 0.250 moles of sucrose. So when I see a problem like this, immediately in my mind, I take this molarity and think of it as the link between moles of the solute, in this case the solute is sucrose, and volume of the solution. So that molarity is going to be a conversion factor, which means that the other value we're given, 0.250 moles of sucrose, that's going to be our starting point in the calculation. So we start with 0.250 moles of sucrose. We want moles to cancel, so molarity is linking moles and liters. And we know that we're going to need moles in the denominator and liters in the numerator. And we need it set up this way so that we can make our moles cancel and end up with volume. So just as before, when we were considering this, that number always tells us how many moles of solute are there per liter of solution. So that 0.760 is going to go in the denominator. So we have 0.760 moles for every 1 liter of solution, and by setting it up with 1 liter on top, we convert from the moles of sucrose to the volume of the solution containing that number of moles. Our last step is a liter to milliliter conversion because our problem asked us to figure out what would the volume be in milliliters, and when we run the calculation, we end up with 329 milliliters of solution. In the description of this video, you will find a link to a Google form that gives you a chance to try 4 of these problems, so please take a look at that. Thanks for watching. Have a great day.